I am Mrs. Smith. I am a teacher. My students and I would like to play our favorite game with you. It's called the Right Wrong Game. We play this game so we can learn how to think like a mathematician. A mathematician is a person who thinks about numbers and how to solve number problems. Now, here are my students who will help you play the game.
Hi, I'm Robin.
And I'm Rob.
We love the Right Wrong Game. It helps us learn a lot about numbers. We are going to teach you how to play the game.
After a teacher asks a question, we will say an answer. We want you to guess if our answer is right or wrong. But be careful, we might try to fool you.
If we say a right answer, you would circle the smiley.
If we say a wrong answer, you would circle the frowny.
Rob, what is this?
That's a cat.
Rob, you are so silly. That's a dog. I'm going to circle the frowny because you said a wrong answer.
Good choice, Robin. I didn't fool you this time. Let's try another.
I have one apple and then get one more. How many apples do I have now?
One apple and one apple makes two apples. You have two apples.
Robin is right. I am going to circle the smiley.
Good choice, Rob.
Okay, let's play.
Remember, if you see us or another student give a right answer, you would circle the smiley. And if you see a student give a wrong answer, you would circle the frowny.
Ready? Here is a practice problem.
How many bears are there?
3 bears. Circle the smiley if you think I gave a right answer. And circle the frowny if you think I gave a wrong answer. Now go ahead and make your choice.
If you circled the frowny, you were right. You were thinking like a mathematician. There are only 2 bears.
Ha ha, I can't fool very many people. Let's try one more.
How many dots are there?
3 dots. 1, 2, 3.
Circle the smiley if you think Rob said a right answer. Circle the frowny if Rob said a wrong answer. If you circled the smiley, you are right. You are thinking like a mathematician.
Okay, here are some more.
In a moment, your teacher will give you a sheet of paper with smiley faces and frowny faces on them. Then, you will see some short videos of children playing the right-wrong game. After you watch each video, decide if the student's answer is right or wrong. If you think it is right, circle the smiley face. If you think it is wrong, then circle the frowny face. Have fun, and thank you for playing.
Now I would like to invite you to join 2 of my students to play the Right Wrong game. Have fun! Challenge 1. Look at these pictures of different dominoes. Which 2 sets of dominoes could represent the number 9?
In the first picture, I see a 2, a 4, and a 2. So that can't be 9. In the second picture, there is a 3 and a 2, and that makes 5. And 4 more equals 9. The last picture is 3, and 6 more, that's 9. So, domino B and C both equal 9. My answer is the second and the third sets make 9.
Challenge 2. Look at these pictures of different dominoes. Which 2 sets of dominoes could represent the number 14?
I don't think it is the first one. It's the last 2 sets of dominoes. They make 14.
Challenge 3. Are these statements equal?
No, these are not equal because the numbers are in a different order.
Challenge 4. Here is a number scale. When I place a number problem on one side that is equal to the number problem on the other side, the scale will balance. If I put two number problems that are not equal on the scale will not balance. Here are more number problems. Tell me the color of the two number problems that are equal and will balance the number scale.
The red and green number problems are equal.
Challenge number 5. Here is another problem. Tell me the color of the two number problems that are equal and will balance the number scale.
The red and blue number problems are equal.
Challenge number 6. Here are two 10 frames. Can you tell me how many red dots you see?
There are 8 in this 10 frame, and the same number in the bottom 10 frame. 8 and 8 equals 16.
I like how you used what you knew about numbers to solve this problem. This is 16. This is the 6 in 16. Show me, what does the number 1 represent in the quantity 16?
This is what the 1 in 16 represents.
Challenge number 7. Here is one way to show the number 23. Each long rectangle is a 10. There are two long rectangles that represent 20. The smaller cubes are ones. There are 3 cubes or ones. Here are some more 10s and 1s. Can you show me a different way to represent 23?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then 10 is 23.
Challenge 8. I'm going to show you two 10 frames. Can you tell me how many are in this one?
9.
Can you tell me how many are in the bottom 10 frame?
8.
Tell me how many dots there are altogether.
This one would go here. So 10 plus 7 more equals 17.
Challenge number 9. I'm going to show you some numbers. One of them is missing in this sequence. 1, 2, 4. Can you tell me what number is missing?
3.
Here is another sequence of numbers. What number is missing in this sequence?
62.
Challenge number 10. 327 can be represented with 327 ones. This quantity can also be represented with 300s and how many ones?
27 ones.
Challenge number 11. 408 can be represented with 400s and 8 ones. This quantity can also be represented with 8 ones and how many tens?
There are 0 tens in the number 408.
Challenge number 12. This is part of a hundreds chart. What number is in the gray box?
It's 52,
How do you know that?
because 32, 42, 52.
Challenge number 13. Here is a story problem for you to solve. Martin sold 37 bags of popcorn on Monday. On Tuesday, he sold 23 more bags. How many bags did he sell?
I know if I take the 3 from 23 and add it to 37, that would make 40. Then, if I add the 2 10s from the 20 to the 40, I would have 60 altogether. So it's 60.
Challenge number 14. Can you read this problem to me?
Sure. 9 minus blank equals 4.
How would you solve this problem?
I started at 4 and counted up. 1, 2, 3, 4, 5. The answer is 5.
Challenge number 15. I'd like to show you another math problem. Can you read this to me?
Blank plus 7 equals 16.
How would you solve this problem?
It's 9.
How did you figure that out?
Well, this is the same as 16 minus 7. 16 minus 7 equals 9.
Challenge number 16. I'd like to show you a different problem. Can you solve this problem?
19, 18, 17, 16. It's 16.
Challenge number 17. Pam baked cookies for a party. She gave 19 cookies to her friends. Now Pam has 11 cookies. How many cookies did Pam bake? Let's read the problem again. Pam baked cookies for a party. She gave 19 cookies to her friends. Now Pam has 11 cookies. How many cookies did Pam bake?
Here is 19.
Here is 11.
And if I move this here, it's 10. She baked 10 cookies.
Challenge number 18. Carmen has a rock collection. In the collection, Carmen has 13 rocks. Carmen wants to have 27 rocks before he takes them to school. How many rocks does Carmen need? Let's read the problem again. Carmen had a rock collection. In the collection, Carmen had 13 rocks. Carmen wanted to have 27 rocks before he took them to school. How many rocks does Carmen need?
Carmen needs 40 more rocks. I started at 27 because this is how many he wants to take to school. Then I counted 10 more, and that is 37. And then I counted on 3 more to make my 13, and I landed on 40. Carmen needs 40 more rocks.
Challenge number 19. In a moment, I will show you some yellow dots and some blue dots, quickly. Tell me if there are more blue dots or yellow dots. Let's try a practice problem.
Blue dots.
That's right, there are more blue dots. Let's play again. This time we will use a different amount of dots.
There were more yellow dots.
Challenge number 20. We are going to play another time with a new picture. Tell me if you see more blue or yellow dots.
There are more yellow dots.
Challenge number 21. We are going to play another time with another new picture. Tell me if you see more blue or yellow dots.
There are more blue dots.
Challenge number 22. We are going to play one last time with another new picture. Tell me if you see more blue or yellow dots.
There are more yellow dots.